Let's review the factoring pattern for the difference of two squares. A squared minus b squared. So when you're factoring, after you've checked for greatest common factor, after you've looked at the number of terms and determined that there are two terms that are both perfect squares and they are being subtracted, you'll know that this is the pattern you need to use. You'll break down your a squared into two factors that are just alike, a times a, and your b squared into two factors that are just alike, b times b. And it will factor as two binomials, a plus b and a minus b, where a is one of the factors of a squared and b is one of the factors of b squared. So, for example, let's say you have 4x squared minus 100. Now, before you look to see if it is a binomial pattern, you first must look for a greatest common factor. So I look at these two terms and I realize that 4 can be taken out of these two terms, and it will give me a binomial, x squared minus 25. Now, I don't want to forget that this 4 is in my answer because I'm required to have the greatest common factor in my answer, but I'll just bring it down so that I don't forget it, and now I can focus on x squared minus 25. X can factor as x times x, and 25 can factor as 5 times 5. So my a is x and my b is 5. So I take x plus 5 and x minus 5. And that is the way that I factor the x squared minus 25. My final answer is 4 times x plus 5 times x minus 5. That is the difference of squares. Now, a related pattern is a squared plus b squared. But because this is a binomial, this is going to be prime because there's no way to factor a squared plus b squared so that you only get two terms. It's not a plus b, because when you distribute this out, you get a squared plus ab plus ba, which is also ab, plus b squared. So you get 2ab in the middle, not just a squared plus b squared. So if you have the sum of squares, if there's no greatest common factor, then it's going to be prime.